Okay, ladies and gentlemen, this is the Poisson probability distribution web work that I have. I usually assign for homework. I'm going to go over the solutions here for you guys on these, okay? Now, this is Poisson. This is the Poisson distribution. We just got through doing the binomial. Okay? All right. Now, ladies and gentlemen, let's see here. Let's read this here. What it says here, if the random variable x has a Poisson distribution. Now remember, for Poisson, you always have to have a mean. They're saying your mean here is 4. This is mu. Find the probability that x is 7. So for the Poisson, this is p of 7 here. Okay, we're going to see what this is approximately. So number 1 is a pretty straightforward kind of question. We're going to go over to the TI calculator here. Okay? Now, this time for Poisson, you hit second distribution. We got to go all the way down to, I believe it was D. This is Poisson PDF, Poisson probability distribution function, probability density function, Poisson. Hit enter. Now, mu, like I said, has to be given. We have to know the value of mu. And in this question, they're saying x is 7. So that's all they want us to do. It's almost like saying, can you use the calculator here, right? And so remember this. This is kind of a bit odd because, you know, they didn't tell us what place value. And that's kind of a weird thing for us, right? They didn't say place value. So let me express this to you. This is what I would do. If I did question 1 and I said, okay, I got all these values from the calculator. You know what the answer is here? They went out to the nearest tens, 100,000. How many decimal values do they go out to here? 1, 2, 3, 4, 5. I wish they were consistent, but they're not. Look at this. There's some inconsistencies here. So they went out to 5 place values. So 1, 2, 3, 4, 5. Look at the digit to the right there. Right? It's a 0 now. So what does that mean? I do. It means I do nothing. I don't add 1 to the 0. So I throw away all these digits. This is the answer now. 0.05954. Okay? And let's double check see if that's what they gave us. And I'm pretty sure it is. 0.05954. And that's what I would do if whoever wrote the question didn't give me a place value. And there it is, question number 1. So it just looks like they want to see if we can actually use our calculator, right? Look at question 2. What does it say? The random variable x has a Poisson distribution. Now the mean mu, this is our mu. They're going to have to give us a mean, 0.0 or 0.446. Find the probability that x is 0. So just like number 1, this is p of 0. Okay, so we're going to go to the calculator and hit second distribution. We need Poisson now. Okay, there's Poisson. Now my mu, right, is 0.446. So change the mu. 0.446. And in this example, x is 0. Okay, paste that in. And again, we get a place value. Okay. So we're going to put down here in the place value here. So we see the calculator, right? 0.640183. And again, I'm not quite sure. For question 2, it looks like they went out to, again, 1, 2, 3, 4, 5 place values. Yikes. I wish they were just consistent and they would have communicated that to me. So let's see what we do again, just like before. 1, 2, 3, 4, 5. We look at the digit to the right. It's a 3. And remember what that means. We do nothing. We don't add anything to the 8. So, ladies and gentlemen, we don't add to the 8. So 0.64018. And let's double check. Number 2. Yep, looks like we're good. All right. Okay. Let's do number 3 now. So I'm going to erase this so we don't get distracted here. Number 3. It says the Columbia Power Company experiences power failures with a mean of, they got to give us the mean, they got to give us the past, 0.210 power failures per day. Now the interval here is in a day. So the average is 0.210. Find the probability that there are exactly 2 power failures in a day. So, what does that mean? What does exactly 2 mean? Okay, that's just P of 2. Exactly 2, that just means P of 2. So, I don't know, maybe we want to keep that important information. Purple. It's exactly 2, okay? So, this is going to be another calculator kind of question. So, go to the calculator. And now my mu again is going to be different. So, we're going to say second distribution. This is Poisson. And this is 0.210, or just 0.21. Now, remember what x was. X in this question is 2. So we say x is 2. Go back and paste this. So you get, ladies and gentlemen, an answer. This is 0.01787. I'll add another digit, 3. And when I go back to the worksheet, I'm not even sure number 3. They're going to the thousands, 3 decimal places, 1, 2, 3. So what I would do, if this was my homework, I'd say, okay, where's my decimal places here? Tens, hundred, thousands. Look at the digit to the right. Ensure is an 8. So I have to add 1 to the 7. So sure enough, P of 2 is approximately 0.018. And that is the answer that's in number 3 here. Okay, so it kind of looks like they're just giving us some pretty straightforward questions for Poisson. Good for them. Thank you. All right. Number 4. Number 4. I'm going to erase the prior so it doesn't distract us. We're now on number 4, and it says a computer sale averages. That's the same as a mean, so they're going to have to give us this. And it's 1.5 sales per week now. Okay? 1.5 sales per week. And it says use the Poisson distribution to find the probability that in a randomly selected week, that's the same interval. That's important to know. The number of computers sold is 2. So this is the X. So they want to know what P of 2 is. X is the number of computers that you're selling. The mean, though, is 1.5. So maybe that's important to write down so people know X is the number of computers sold, and that's going to be in a week. That's an important detail. Okay, in the week interval. So that's why it's P of 2. Okay, we're going to see what this is approximately. So mu is now 1.5. So in the TI, let's go TI. Clear that out. Second distribution, this is Poisson now. 1.5 for mu. X is 2 still. Okay. Hit paste. And again, we have that situation of 2510214. There's nothing special about where you're approximating here. But number 4, you go out to 1, 2, 3, 4 decimal places in number 4. So that's what I would do. I'd take a look since they didn't tell me. Look at the digit to the right of the 0. Right? The digit to the right of a 0 is a 2. That means ignore all of this. And so, sure enough, final answer for P of 2 is 0.2510. All right, let's look at number 5 now, ladies and gentlemen. This is number 4, number 5 now. Okay, number 5. Let's see what it says. A naturalist leads whale watching trips every morning in March. The number of whales seen has a Poisson distribution. Remember, X counts the number of arrivals. So it looks like here, X is going to be the number of whales seen. They show up. Okay? So the number of whales seen has a Poisson distribution, and then the mean is 2.2. So they got to give us the pass. And that's, they didn't give us the interval, which is kind of odd. It's kind of a weird question. 2.2, I guess, per day. You know what I mean? So they didn't give us the interval. So Mr. Judge would be clearer than the person that wrote number 5. But anyway, okay. Find the probability that on a randomly selected trip, I guess that's it's a mean 2.2 per trip. They didn't say that. I would have said it. Mean of 2.2 per trip. Find the probability that on a randomly selected trip, the number of whales seen is 5. So, if X is the number of whales seen, this means I want to know X is 5 here. I want to point that out. Number of whales seen is 5, so X is 5. They want to know what P of 5 is. Okay, when mu is 2.2. So this is how we answer number 5, ladies and gentlemen. So go to the TI here. Okay, clear. Second distribution, Poisson. This is Poisson distribution now. Mu is 2.2, and they want to know exactly 5. So, okay, here's 5. Paste that in, ladies and gentlemen. Okay, they're just asking for P of 5 now. Now, again, we don't know where we're approximating. They didn't tell us to begin the question. 0.47586. So, I guess you can say, let's scroll down to number 5 here. And they gave the answer to 4 decimal places for number 5, right? So let's do the same. So that means 1, 2, 3, 4 decimal places. This digit is an 8. You have to look at that digit to the right. That means add 1 since it's an 8. Okay, so P of 5. Let's write down a better P of 5. Add 1 to the 5, and that gives you a 6. Okay, so ladies and gentlemen, let's double check to see if this is number 5, right? The whale watching trip, number 0.0476, sure enough. All right. All right, that's question number 5, ladies and gentlemen. Now let's erase it all. You got a video you can go back and watch. So number 6 here. This is going to be good. Number 6. We may have to start writing things down here. A number of lightning strikes in a year at the top of a particular mountain has a Poisson distribution with a mean of 3.1. So number 6, I'm going to write this down. X is the number of lightning strikes in a year. Number 6. That's what they say in this first portion. And they say more than that. They say with a mean of 3.1. Okay, I'm going to leave it there so you guys can say the number of lightning strikes in a year. That's the interval. Has a Poisson distribution with a mean of 3.1, and that's per year. So they're going to say here, now mu here is 3.1 per year for number 6. Okay? This is what they gave us. And I usually put the mean in purple, so I want to make sure you guys see that. And again, the interval here is in a year. So number 6. Okay, find the probability. This is important. In a randomly selected year, so it's the same exact time interval, that the number of strikes is 5. So they want to know what P of 5, okay? Because the number of strikes, remember here, is X. Number of strikes is 5. So I think we're using purple. Number of strikes is 5, and that means X is 5. So they want to know what P of 5 is for number 6. Number of strikes is 5. X is 5. So number 6, P of 5. What is this approximately? Now we're going to get out the TI. 3.1 is mu. So I'm going to say clear that out. Second distribution, Poisson PDF. 3.1, X is the same number, it's 5. But mu has changed. So let's write these numbers down because they didn't indicate a place value. Excuse me. And, for number 6 here, looks like the answer goes out to, 4 decimal places. So let's do the same. All right. 1, 2, 3, 4. Look at the digit to the right. It's a 7. That means add 1. 1075. Add 1 to the 4. And sure enough, number 6, yes, 0.1075, ladies and gentlemen. That's what we get as a probability. 10.75% of the time, I guess. That's number 6. Okay, number 7 here. Let's get rid of all of our highlights. So let's see what number 7 is going to be here, ladies and gentlemen. 7 here. For a certain fabric, the average number of defects in each square foot is 0.8. So average number of defects, that's mu. Mu is 0.8, defects in a square foot of fabric. So it says, find the probability that in a randomly selected square foot, the fabric will contain more than one defect. So this means the following. X is the number of defects. And that's really per square foot. That's the interval. And they say, okay, what does more than one defect mean? Fabric will contain more than one defect. That's X greater than 1. Okay, this is more than 1. Okay, X is greater than 1. So this is question number 7. So for 7, they want the probability you'll have more than one defect. And I'm going to move this over here. I'm going to say, what does more than 1 mean? That means you have 2. That means you have 3 defects. And that means you go on forever. And that means you're going to die before you finish answering this question, because that includes P of 4, P of 5, P of 6, P of 7, and so on. But you must use to answer this the complement rule. 1 minus P of 0 minus P of 1 here. Okay? Now we're not going to die. We just have to answer, make sure we put 1 minus And find P of 0 minus P of 1, because this is the complement of more than 1. More than 1 is 2 or 3 or 4 or more. Okay? Now, mu, let's not forget mu, because that's going to be important. Without it, we can't answer a question. Say mu is 0.8. Okay, so in our calculator, the Poisson distribution now. Oops, we don't want ITV. See what happens? I hit the wrong thing. Okay. Let me go back to the calculator. Let me quit ITV before I get on TV and something else happens. Calculator. Clear that out. Okay. Don't forget now. 1 minus second distribution, Poisson, PDF. Remember, our mu now is 0.8. The x value would be 0. I'm going to paste this here. Minus second distribution, Poisson. What's your x value? X is 1. You're going to paste this here. Okay. So you did 1 minus P of 0 minus P of 1 here. This is what we did by the complement rule. And 0.19, see what we get, 0.191207, 191207, because ladies and gentlemen, again, you know, this is number 7. We went out to 4 decimal places here. Let's double check. 1, 2, 3, 4. Look at the digit to the right. It's a 0. So sure enough, 1912. And that's exactly the answer they have right here for number 7. Anyway, all right, number 8. Get rid of all this. Number 8. I'm going to get rid of this too. Number 8. What does number 8 say? A mountain search and rescue team receives an average of 0.73 calls per day. All righty. So the mu here is 0.73. This is calls. Now the interval is in a day now, so that's going to be important, okay? So find here, it says, find the probability that on a randomly selected day, it's the same interval, they will receive fewer than 2 calls. So fewer than 2. So number 8 means X is the number of calls, and that's per day. So when they say here, they use the phrase fewer than 2 calls. So that means now fewer. X is less than 2. This is fewer than 2. Less than 2. So it's another way of saying less than 2 calls. Okay? Find the probability that on a randomly selected day, same interval, they'll receive fewer than 2 calls. So P of X less than 2. We know what less than 2 means. That means it's 0 or 1, but it can't be 2. And don't forget the value of mu in this Poisson distribution is 0.73. So Poisson is nice because it only needs 2 values. It needs an X value, which is here, and it needs a mu. So we're going to enter this in the TI now. Okay, so let's clear this out. This is by definition fewer than 2. So we're going to go down to Poisson. Now my mu is 0.73. X is 0. Paste that. Plus, now that's P of 0. We're going to have to add P of 1 now. Poisson. Okay. 1 hit what? Pace. 0 and 1. So, ladies and gentlemen, we're going to write all these values down. Again, we don't know the place value because they didn't indicate. 83.8337025. All right, this is number 8. Now, what did they approximate to? 4 decimal places for number 8. So, we're going to do the same. 1, 2, 3, 4. Look at the digit to the right. It's going to be a 0. So the answer is approximately 0.8337 to 4 decimal places for number 8. And that's pretty much, again, what they have here, which is like 83.37% of the time. You're going to have fewer than 2 calls. And that's per day. So, we haven't been writing down what this portion is, but this is a good example to express. Number 8, you can say, for the mountain search and rescue team that receives an average of 0.73 calls per day, the probability there will be fewer than 2 calls, less than 2 calls, is about 88.37% of the time. So that's kind of how you illustrate this particular question here. It's a pretty nice question. And that leaves us with number 9. So I'm going to erase all of this here. And number 9 now here, right? So let's read number 9. What does it say? And I'm going to erase this so it doesn't distract us, right? It says the number of calls received by a car towing service averages. So number of calls. Averages, that's a mean. 2.16 calls per day. Now we've been making, we've been talking about this. Maybe I'll get rid of 8 as well because this is similar to I'll get rid of 8, similar to number 9. So it's really the number of calls, like the number of emergency calls you get. So let's write this down, and this is car towing, so whatever, number of calls. So X is the number, we're going to write this down here, okay? Let's not write it yet. So what do we know? We know that mu is 21.6 really calls per day. That's the interval. And now here's the question. It's kind of interesting. They say the following here on this. They say after finding the mean number of calls per hour. All right, after finding the mean number of calls per hour, they gave us the calls per day. We're going to see how that works. The question is, find the probability that in a randomly selected hour, the number of calls is 1. So number of calls is 1. So I'm going to say X is the number of calls. And because I want to say X is 1. Remember that? We want to say this. Number of calls is 1. There we go. X is 1. But that's now in a different interval because they're saying find the probability that in a selected what? Hour now. So X is the number of calls, not per day, but per hour. This is a different interval. So I'm going to highlight this, ladies and gentlemen. This is going to be opening the door to some other idea we have to do first. Now, they gave us 21.6 calls per day. And remember what is in a day. There's 24 hours in a day. That's why they keep telling us that. So we're going to have to convert our mu because X is in terms of, to say X is 1, X is the number of calls per hour. So this becomes a question where we need a new mu. So what is mu per hour? How many calls you get in an hour? So you're going to have to convert, ladies and gentlemen. Now, let me show you guys how to do that. You have to create a proportion. equal ratios. Now you say, what does that mean? They gave you 21.6 calls. This is per to divide in 24 hours. Okay? That's going to be the same as, I'm going to have a new mu. Mu. And it's mu calls per hour. Okay, this is an important detail because, yes, they gave us this kind of call, and this is what they said, and this is per day, right? 21.6 calls per day. So I'm going to have to use the idea that there's 24 hours in a day. I have to convert. Now, when you convert, it's important to know that you got to have the same units. Calls will have to be on top, and hours have to be on bottom. You have to be consistent. And so what that means now is if I do this division here, you see this mu? I'm going to have to do this division over here. 21.6 divided by 24. That's going to give me my mu in hours. And that's an important detail. I need mu in hours. So I take 21.6. Let's clear this out. Let's go to the TI. 21.6 divided by the 24 hours gives me 0.9, ladies and gentlemen. And what that means is that's 0.9 calls per hour. So this is now in the hour interval. Right down in here. This is calls per hour. So here's my new mu. Mu is 0.9 calls per now hour. And that, ladies and gentlemen, is the key to answering this question. You got to convert 21.6 per day to 0.9 per hour because the question right in here is in hours. Find the probability that in a randomly selected hour, they change the interval. All right. Number of calls is 1. So you're going to say, okay, what is P of 1 now? Because X is 1. But the mu is 0.9. So you're going to have to change that there. So I'm going to give you more information to look at this here for a quick second. We're going to get out the calculator now, right? Second distribution. Go to Poisson now. And in Poisson, mu is 0.9. That's in calls per hour. X is still 1, so that's great. We get this answer here. We know that they gave us 1, 2, 3, 4, 5 place values. So I have to write down 3, 6, 5, 9, 1, 2, 6, 9. Okay. They gave the answer to 5 place values. 1, 2, 3, 4, 5. Look at the digit to the right. It's a 2. So that means this is your final answer. So the probability there'll be 1 call per day is 0.36591. And in some ways, you really can just say here that 36.591% of the time, because notice this is the answer, 36.591% of the time, you get 1 call. And that's in an hour. So the interval was changed to an hour, even though they gave you mu per day. And ladies and gentlemen, there you go. That's how we answer these Poisson questions. And pretty good. Okay, so I hope you guys enjoyed this. We're going to link it to the homework page, and we'll see you guys later.